a new topic on drying oils. Up till now, you have learned oil technology, the classification of oils and fats, and many things, but they were related either to use of oil in food, bakery, or cosmetics, or soaps, or other items. Now, our focus is mainly where and how oils are used in paint, printing inks, and varnish industry. Means we will look at the oil from the viewpoint of a paint technologist. Remember. Now our outlook will be little bit different. We will visualize various oils from the angle of a paint technologist. How far an oil is useful in paints. So first such effort, you can write down, Hilditch has made first time the classification of oil, and he has divided oil into three categories. One, non-drying oils. Non-drying oils. The iodine value is 0 to 120. They are known as non-drying oils. Here, iodine value indicates the unsaturation present in the fatty acid molecule. Now, if there is an unsaturation, it is always responding to oxidation, is it not? The more the unsaturation, the more the possibility of drying, polymerization, the less the unsaturation, less the reactivity. To give you an example, coconut oil has an iodine value of 10 to 15. And linseed oil has an iodine value of 180 to 190. So as a paint material, coconut is of least importance. While linseed oil with an iodine value of 180 to 190 is a very important raw material for the paint industry. So higher the iodine value, better it is for utilization in paints. Lower the iodine value, better it is utilized. It can be utilized in other purposes. This is the basic. Hilditch has given a constant which is known as drying index. You can now go to page 1. Page 1. Please open on your WhatsApp page 1. Have you opened?
Yes, sir.
Now here, drying index is nothing but percent of linoleic acid, plus 2 into percent of linolenic acid. Linolenic means 3 double bonds. Linoleic means 2 double bonds. I think you must revise it. Linoleic means 2 double bonds in the molecule. Linolenic means 3 double bonds in the molecule. Okay. So drying index is nothing but percent linoleic acid plus 2 into percent linolenic acid present in the given oil. So 0 to 120 is non-drying oil, 120 to 150 is semi-drying oil. And above 150 is drying oil. This is a broad classification from paint angle. When IV crosses 150 or above, then we call that oil useful as a paint material. When it comes down, say come to 120, 130, some of the composition may utilize those semi-drying oils. Therefore, they are called as semi-drying oils. They can also be utilized, but with limitations. And non-drying oils, only in very exceptional cases we use coconut oil, not otherwise. Whenever we are making a baking finish, then a small proportion of coconut may go but coconut oil is not a desirable oil for paint industry. Okay, so first in the series is linseed oil. This is also known as flaxseed oil. And if you go to the, please see page 2 first. Go to page 2 on your WhatsApp. Here we have given the production of linseed in India. In 2017, we have maximum production of 184,000 metric tons of linseed oil in India, while it is dwindling down 218, 174,000 metric tons, 219, 99, and in 2020 it is 103,000 metric tons. In fact, our most of the oils which are used in paint industry, they are being going towards edible purpose. Omega acid is present in linseed oil, is it not? This omega acid is very much required for your health. So a part of linseed oil is diverted towards edible purpose, is it not? So available, and another important factor of popularizing a oil is what is the per hectare yield for the farmer. Always in the case of oilseed, remember that per hectare yield is very important criteria, because if the farmer earns better in soybean, he will go for soybean. If he gets per hectare 10,000 rupees more in soybean, he will not go for seed of linseed, is it not? So per hectare yield, the varieties are also important. What kind of varieties are there and what much oil yield is there. Normally linseed को अपन हिंदी में अलसी का तेल बोलते, अलसी और फ्लैक्ससीड, ऐसा छोटा काले रंग का जवस म्हणतो आपण त्याला, and the oil content is around 40%. Oil content is around 40%. If you go to Multai or central parts of India and few other places, there is some production of linseed oil, and particularly that is because linseed oil is specially priced for paint making, is it not? So now go back to table number 1 or your attachment number 1 once again. Just see the composition of linseed oil. Always remember that behavior and property, utilization, everything is related to composition. If you know the composition, you can understand that oil. The basic thing which you should know about oil is its fatty acid composition. So linseed oil, if you look at the composition as given here, the linolenic or 3 double bond fatty acid is maximum 40 to 50%. Try to note down. What is the linolenic content? 40 to 50. And this makes it more useful as a paint raw material. Then comes oleic acid. Sorry, linoleic, that is 2 double bonds, that is 20 to 30%. 20 to 30%. Then oleic is 13 to 29%. And stearic is 6 to 12%. Always remember that in drying oil, normally the saturated should not go beyond 5 to 8%. If it goes beyond that, because stearic acid, formic acid, they will not allow the material to dry. They are 100% saturated. So one specific property with linseed is the fact that its saturated content should be very low, say 6 to 12%. And its iodine value is 180 to 190. Highest iodine value among available oils, 180 to 190. And it is drying index When the drying index, that means percent of linoleic plus 2 into percent of linolenic acid, it is 100 to 130. This drying index tells you that how much the oil is suitable for paints. If it is around 100 and above 100, then we use it more in paints. If it is below 100, then its use as a paint is questionable, always. So drying index, if it is more than 100 or above, we consider that oil as a good drying oil. The second in the series of drying oils is perilla oil. Perilla, Perilla, perilla oil. In India, particularly in Assam, Meghalaya and Tripura, you get this perilla oil. But it is more going into food products because its medicinal uses are very good. For heart and other problems, this oil is specifically recommended. So, Bhang Jeera or Radhuji, this is the local names. But the production is very less, around 40,000 metric tons. In fact, this oil needs more attention. We should make greater production of this particular oil because it has a very specific nature of 60 to 68% linolenic acid. Just see the table. Compared to linseed oil, it is superior. How much oil? How much linolenic? 3 double bonds, 60 to 68. Then linoleic is 15, oleic is 14 to 21, and stearic is 6 to 14. 6 to 11, sorry. Iodine value is 200, highest in the list. Therefore, the best for paint industry. Drying index is also more than linseed, about 145, but perilla oil is not available in commercial quantity, remember. This has got good prospect as a material for paints, but its large-scale commercial production is not there throughout the world. So here I feel there is some potential of having more crop of perilla and producing more perilla oil for paints. Okay. The next is soybean. I think all of you know much about soybean oil, so we do not go much into its details. The specific feature we make soybean oil more important is 5% linolenic acid. In other edible oils, linolenic is not there, while soybean is having linolenic acid. Have you tested soya milk at some stage? Soya milk, कितने लोगों ने पी के देखा है बताओ मेरे को, कभी न कभी. Mr. Kothari from industry, he is pioneer rather in making soya milk. So I asked them that why soya milk is not so popular. Why? This 5% is the basic problem. Linoleic, it gives a offbeat fish-like taste. तो सोया मिल्क पीने के बाद में आपने नहीं पिया है, मैंने पी के देखा है, तो बाद में ऐसा अनप्लीजेंट फीलिंग आता थोड़ा सा, because of the flavor and odor which is created by this linolenic acid. The major fatty acid which is present is linoleic. Oleic is also there, but saturated is higher. That is not desirable. Therefore, soybean is not a desirable. Of course, in some non-yellowing alkyd preparations it goes, but it is not a desirable, largely used oil in paints. It is used in small quantity when non-yellowing is important. Iodine value 120 to 135 and drying index is slightly lower. That is 65 to 70. Particularly, we use soybean in penta-long-oil alkyds, penta-long-oil alkyd preparations, where non-yellowing is important. I will explain you what is yellowing and non-yellowing, but particular use of soybean is in alkyd preparation, which is based on pentaerythritol and mainly used for non-yellowing behavior of soybean. Then the next oil in the list is tung oil. Tung oil is a very unique oil produced in China from tung fruit. Its composition is also unique. It is अल्फा एलियोस्टेरिक एसिड. अगर भूल गए हैं तो थोड़ा लिख लीजिए कि ये अल्फा एलियोस्टेरिक एसिड क्या है. It is 9-cis, write down please, 9-cis, 11 trans, 13 trans, octadecay trinoic acid. 9, 11, 13 octadecay trinoic acid. Octadecay trinoic acid. This is unique. No other oil is containing this particular acid, and about this alpha eliosteric acid, I will tell you that it is perhaps the only commercial oil in which the double bonds are conjugated. 9, 11, if there is an alternation of single bond, double bond, single bond, double bond, then it becomes a highly reactive system. The bonds are formed by pi and rho bonds. Pi bonds are labile, while rho bonds are stable. So these pi electrons, they move around the system, and whenever there is conjugation का मतलब समझो, conjugation and alternation, one single bond, then double bond, one single bond, then double bond. This is known as alternation, and this is known as conjugated double bond. It confers a special reactivity in the product. Why? Because pi electrons are mobile. They form a cloud around the system, and it makes it highly reactive, even sometimes better than linolenic acid. It is present in tung oil to the extent of 75 to 82%. Oleic is 11 to 14, stearic is 4 to 8. It is difficult to determine its iodine value because of the particular structure. So it has not been mentioned here. Drying index is 150 to 160. Fast drying, very good oil for paint industry. But the limitation of tung oil is only in few countries, either South American countries or China. These are the two sources from where you can get tung oil. No commercial production of tung oil is there in India. In fact, if we need tung oil for some specific purpose, we have to import it. Is it not? Last but not the least is dehydrated castor oil. What is this dehydrated castor oil? Try to understand the meaning of dehydrated castor oil. I had been to Hyderabad for consultancy with a firm which was dealing with this castor oil. So dehydrated castor oil means heat castor oil at a very high temperature, say 270 to 275 degrees, add sodium bisulfate and bisulfite as a catalyst. In 2-3 hours, the resinolic acid, which is present in castor oil, it is converted to a fatty acid parallel to linoleic acid, but this fatty acid has 9-11 double bond. Means conjugated double bond 1/3 are there in dehydrated castor oil, about 80 to 85%. Oleic is 7%, stearic is 10%, and drying index is 80 to 85. If you ask me to compare, linseed perilla is the best, tung is also the best, and dehydrated castor oil particularly in making alkyd resins or other paint preparations. This dehydrated castor oil is also equally important. Let us try to understand that what is the production of castor oil in India. Because all the materials which we are discussing, we must know that what is their status in India. Because otherwise, what kind of technology we will develop. So, the castor production this year is 1.2 million metric tons. 1.2 million metric tons. 3 companies are working on castor oil. One is Adani Wilmar. Another is Jayant Agro. This is the oldest company. From last 20 years, they are dealing mainly in castor oil. Then Gokul Overseas and Kandla Agrochemicals. These are the 4 major companies we are dealing in castor production. And mainly castor is grown in Gujarat, Banaskantha, Gandhinagar, Kutch, Mehsana, Rajkot. It is also there in Andhra Pradesh. In Andhra Pradesh also castor is, and our Indian agricultural scientists have developed good grades of castor seed, and therefore you can take a better crop, better per hectare yield, and therefore castor oil is becoming popular. In Maharashtra, particularly in and around Nagpur, the castor trees are planted as fencing to the various farms. To a big field where you are growing either gehu or jowar. So on the periphery of the whole farm, castor trees are planted. Why? Because castor is not eaten up by animals. It has got a poisonous element called as resin, and therefore animals do not touch it. Therefore, as a fencing, but the per hectare yield is also good in castor. The per hectare yield is around 1.7 metric tons per hectare. Per hectare yield of castor is 1.7 metric tons per hectare. And a large area of land, 9,92,000 hectares, is used for castor production. It is a coming up item because you can have 2 crops. It is very high in oil yield, not edible. But there are n number of alternative industrial products about which we will talk later on. So this is all about castor oil. Okay. Now, one thing today I would like to tell you more in detail is to understand the chemistry of oxidation. What you should understand? Chemistry of oxidation. Oxidation and thermal polymerization. Always remember that when you want to understand something, we call it chemistry. आप हमेशा पढ़ते होंगे कि वो पिक्चर में हीरो हीरोइन की केमिस्ट्री बहुत अच्छी थी, हैं? लोग ऐसा नहीं बोलते कि फिजिक्स और मैथमेटिक्स अच्छा था, क्या बोलते हैं? The chemistry between the two was good. So I would also say that if you understand the chemistry, the real difficulty with chemical technologies is this, that we have more engineering element, but basic chemistry people have forgotten. If you know the chemistry, then you understand the material, how to modify it, what are the problems, why it is getting polymerized, why it is spoiling. All these things, if you want to understand, you should know the chemistry of oxidation, thermal polymerization, etc. So this portion of my lecture, I want to devote to understanding the chemistry of oxidative and thermal polymerization. Try to understand it. One simple question I would ask, what is the difference between ion and free radical? Can anybody tell difference between ion and free radical?
Ion has positive or negative charge, and free radical do not have charge.
Yes, correct. I will give a more simple example. Sodium chloride, salt, NaCl. You dissolve it in oil. You get Na plus ions, means whatever bond which is making NaCl, it is broken down. The electron pair goes to chlorine and therefore it is negatively charged. And as sodium is losing an electron pair, therefore we charge it as positive. This is ionization. Okay. But in free radicals, suppose there is a chlorine molecule. Chlorine molecule. If it ruptures into free radicals, means one chlorine will have one unpaired electron, another chlorine will have unpaired electron. So group of atoms or atoms which have unpaired electrons, they are known as free radicals. And all the chemistry has now been explained in terms of free radicals. Simple. Suppose all molecules or substances, they are linked together by some bonds. Sodium chloride, when you break the bond, the thread goes to the chlorine and it remains deficient. While chlorine, if you cut in between, a part of electron goes to one unpaired electron while other goes to other chlorine atom. But this unpaired electron is very sensitive. Remember that unpaired electron is very, very reactive and it cannot remain free. Although we call it as free radical, but it cannot remain free. It will have a tendency to go into some chemical reaction very early. And now experiments have been conducted in which the presence of these free radicals has been experimentally identified. Okay. Now go back to page 1. Page 1 के नीचे कुछ लिखा हुआ है, देखो. Can you see it? At the bottom something is written. Please refer it. Now here I am writing down the structure of a fatty acid in which a CH2 group is enclosed between two double bonds. On one side there is a double bond, other side there is also a double bond. Okay. And this CH2 I can write as CHH as it is written here. Okay. So this fatty acid as a whole I can write this remaining structure, I put it as R, and this H separately I write and call it as RH. To understand or simplify, whatever is the remaining structure, I put it as R, and this CHH, H I put here and call it RH. Okay. So first stage, when it reacts with oxygen, the first stage is formation of peroxide. Now you can switch over to page 3. Please switch over to page 3. First step is formation of hydroperoxide. Lot of discussion has been done that what products are formed, but now the analytical tools of instrumentation are so accurate that we can easily find a proof for all the things which we write on the piece of paper. This RH will react with oxygen. Likho bhai isko. Please have a pen in your hand and copy it. RH plus O2. RH plus O2. What you get is a hydroperoxide. Now this hydroperoxide is a very, very reactive entity. Hydroperoxide is highly reactive. It will not remain as such. It is an unstable species. So next step is breaking of hydroperoxide into two free radicals, RO plus OH. We get two free radicals, RO plus OH. Write down. With pen you write down, you will understand better. ROOH, it is converted to RO plus OH. RO is a free radical, OH is a free radical. Okay? समझने की कोशिश करो. If you understand this, all the polymerization you will be able to grasp properly. What is happening? First, formation of hydroperoxide by reaction with oxygen. Then this hydroperoxide is broken up into two free radicals, RO plus OH. This RO can react with original molecule RH. RO can react with original molecule RH. Please write down with pen. It is better. RH plus RO, that is converted to ROH plus R. The other possibility is RH plus OH. RH plus OH free radical. So again you get R plus water. So now if you look at the system, there are three free radicals. One is RO, other is R, the third one is OH. These three free radicals are present in the system. Now, based on these three free radicals, we can certainly make all kinds of linkages which are there in the polymerized molecule. First is, if RO and OR reacts, RO plus OR, write down, RO plus OR, that will give you ROOR. This is known as peroxide linkage. This is known as peroxide linkage. The next is RO will react with R. RO will react with R and form ROOR. This is ether linkage. This is ether linkage. If R and R combine, they will give RR, which is carbon-carbon linkage. If R reacts with OH, then we get ROH, that is hydroxylated ester. In the oxidized product, all these linkages have been physically verified. We are doing various testing of the dried material, thermally polymerized material, and in that thermally polymerized material, the presence of peroxide, ether, CC bond and ROH can be detected by instrumentation technique. Means what we are writing, it has got an experimental proof. What I do, I take the oil, subject it to oxidation, analyze it, and in analysis, I study the presence of peroxide linkage, presence of ether linkage, presence of carbon-carbon linkage, and presence of ROH linkage. So all these linkages have been experimentally verified. Quite simple. If I take the oil, treat it with oxygen, even if I heat it, then various products are formed, which are higher in molecular weight, absorbing about 8 to 16% oxygen. So all these products chemically you can explain with this simple explanation. एक बार और बता देते, that you should never forget. Okay, what is that? Try to understand. First RH I have written fatty acid CH2 जो दो डबल बॉन्ड्स के बीच में है उसका CH2 को मैं CH लिखता हूं और पूरे सिस्टम को R लिखता हूं और इसको फ्री हाइड्रोजन को H लिखता हूं. ठीक है. Reacted with oxygen I get hydroperoxide. Hydroperoxide then breaks up and gives rise to two free radicals RO plus OH. Then I have two free radicals now, ROOH, and already RH is there in the system. So RH will react and give a free radical R. RH will also react with OH and give another free radical R. So in these reactions, three free radicals are produced. One is R, another is OR, and third one is OH. Okay. These free radicals now can react. RO will react with OR and will give peroxide linkage. RO will react with R and will give ether linkage. R will react, form RR, a carbon-carbon linkage. R will react with OH and form hydroxylated ester. If I study the chemistry of the either thermally polymerized or air oxidized polymeric film, then all these linkages have been physically verified. So it is just not just an idea, it is a truth that this is happening. Because giving mechanism is something good, but you should have a practical proof. For whatever you are proposing, you have to give a practical proof. So this is the proof for the whole issue. Okay. Now, next thing which I want to do is about oxidation of tung oil or wood oil. Go to page number 4. Please go to page number 4. Open your pen and paper also and try to write down. Then the understanding will be better. Here you have two molecules of alpha allosteric acid, conjugated double bonds, 9, 11, 13. One double bond at 9 position, second double bond at 11 position, third double bond at 13 position. So here you have in this conjugated system, there is one pi electron and other is rho electron. Rho bond is stronger. Pi electron can move over the system and form a cloud of reactivity. A higher reactivity is conferred upon by this particular system. And we react it with oxygen and we get a product with oxygen bridges as shown in the text. Two molecules of such alpha allosteric acid will be linked together with oxygen. And this will rearrange. And by rearranging, we get this product in which one group is CHOH here and another group is CHOH here, and again oxygen is there, and therefore this whole thing gets thickened up. That is how we explain the possibility of oxidation of tung oil. Okay. Last but not the least is thermal polymerization of drying oils. You know that suppose I heat linseed oil at a high temperature, say 275 degrees, then with time it will go on thickening. In 1 hour it will be less thickened. In 2-3 hours it will thicken faster. In 4 hours or 8 hours it will be converted into a thick viscous liquid, which is known as tanned oil. Okay. So you can alter the viscosity and character of linseed oil by heating it at very high temperature. One thing I would like to mention here, that this particular thermal polymerization occurs at a very high temperature, 275 to 285 degrees. At 250 degrees, being long chain length, below 250, I have also tried in many ways, but polymerization is not practically possible. If you invent a catalyst by which you can bring this change at a lower temperature, say 100 degrees, 40 degrees, 150 degrees, it will be a great achievement. But nobody has been done. I have tried this for several years, but yet the real polymerization starts at what temperature? 275 to 285 degrees. At this temperature, when you heat the oil, there is one non-conjugated linolenic acid. Its structure is written. Just see it. CH double bond CH, CH2, CH double bond CH. This is the structure of linolenic acid. So when you heat it, there is a isomerization, and from non-conjugated, it is converted to a conjugated form. What is the basic thing happening? The non-conjugated double bonds, due to high temperature, they get converted first into conjugated form. Conjugated means alternative single double bonds. These two molecules, conjugated and non-conjugated, they react. Conjugated double bonds, they react and add to each other by a reaction which is known as DIELS, Diels-Alder reaction. 1,4 addition or Diels-Alder reaction. Means two fatty acids will form a dimer. It can go further to trimer. It can go further to tetramer. Okay. But linking of the fatty acid is not possible at lower temperature. You have to go to very high temperature. This is the main difficulty in using the oil and spending too much energy on heating. But without that, perhaps nature has made the things difficult, because oil for utilization, it should be stable. So at lower temperatures, its stability is not affected at all. But when you heat it at a very high temperature, then at high temperature, there is a conversion from non-conjugated to conjugated double bond. These conjugated double bonds, they are sensitive and reactive. Because of the pi electrons, they react, and by 1,4 addition, we call it as 1,4 Diels-Alder addition reaction. That is how thermal polymerization of drying oil occurs. So now we have entered into drying oils. In some way we know the composition, the oil content, the properties and other things. And from a different perspective, we are trying to understand linseed, soya, dehydrated castor oil, then perilla oil, soybean oil, and we are trying to evaluate them from the angle of a paint technologist. We are evaluating them in terms of drying index. I think that is sufficient for today. Teaching more chemistry, you may not like it. थोड़ा जल्दी बोर हो जाता है ना? But that is sufficient. That is required. I can't help it. तो थोड़ा सा इसको रिवाइज करो, इसको लिखो. You can ask questions now, whatever you want.
सर लेनोलेनिक में कॉन्जुगेशन होता क्या सर?
क्या?
लेनोलेनिक.
मेरे को आवाज क्लियर नहीं आ रही, थोड़ा पास से बोलो थोड़ा सा.
सर लेनोलेनिक में कॉन्जुगेशन होता क्या सर?
लिनोलिनिक में 9, 12, 15 नॉन कॉन्जुगेटेड है।
ओके
9, 12, 15 यानी एक CH2 ग्रुप बीच में रहता है ना। तो जब आप उसको हीट करते हो, when you
यस
take
सर
it to a very high temperature, say 275 degrees or something, then at that temperature there occurs a change. There is a process known as isomerization. Isomerization from non-conjugated to conjugated form. And once that conjugated form is prepared in the synthesis, that will react, the molecules will react with each other very easily, and by Diels-Alder addition reaction, they will form dimer, trimer, tetramer, etc. And therefore, Stand Oil, which has just a viscosity of few poise initially, it can go to 4 cup, 20 minutes, 30 minutes, etc. Very high viscosities are developed in Stand Oil. Why? Because conversion from non-conjugated to conjugated and making dimer, trimer, or even tetramer sometimes. The same reaction is good for paint, but the same reaction is bad for edible purpose. Remember it. This reaction is good for drying of paints, but if you eat it, the polymerized oils are a little carcinogenic to our system. We are not supposed to consume polymerized oils. जैसे आपका समोसा रहता है, समोसा बनता है ना, तो वो एक बार का ऑयल यूज करो तो ठीक रहता है, और समोसे वाले को तेल बचाना रहता है, तो वो क्या करता है, उसमें दूसरी बार निकालता है और पॉलीमराइज होता है वो, फिर से तीसरी बार निकालता है और पॉलीमराइज होता है वो। और एक और बात अंदर की बता दूं मैं होटल वालों की, कि वो समोसा जो रहता है ना, वो पहले के अगर 10 समोसे बचे हैं तो आगे के 100 समोसे में मिक्स कर देते हैं। तो उससे क्या होता है कि आज जो आप समोसा खा रहे हो उसमें पिछले साल का रेसिड्यू भी होगा कुछ न कुछ। दैट इज द रियलिटी। क्या होता है, इसके लिए थोड़ा हल्दीराम ने बहुत अच्छे इक्विपमेंट्स लिए हैं। उसमें हीट ट्रांसफर का प्रिंसिपल किया है, यानी जो अपन जैसे कढ़ाई में गर्म करते हैं ऑयल को, है ना, तो ऑयल को बहुत हाई टेम्परेचर पे गर्म करते हैं, तो इतना हाई टेम्परेचर की एक्चुअली जरूरत नहीं है, तो उसने हीट एक्सचेंजर्स लगाया। ऐसा मैंने डिजाइन देखा, यहाँ पे किसी ने डेमोन्स्ट्रेट किया था किसी सेमिनार में, तो उन्होंने ऐसे हीट एक्सचेंजर लगाया कि एक पर्टिकुलर टेम्परेचर के बाद जो हीट जनरेट होती है उसको रिसाइकल कर देते हैं, बहुत ज्यादा गर्म नहीं करते। और उसमें एक प्रॉब्लम है, अपने लोगों को फ्राइंग में जब तक वो पॉलीमराइज नहीं आता उसका टेस्ट नहीं आता। क्या है, जो लाइटर वे में जो बनाते हैं उसका टेस्ट उतना अच्छा नहीं लगता है अपने को, बिकॉज वी आर हैबिचुएटेड टू दैट हाई डिग्री ऑफ फ्राइंग, इज इट नॉट? Now, one very interesting proposal given by Vijay and myself to these hoteliers was this, that let us, after 2 or 3 times, the oil should not be reused. It should be converted into grease. That was our proposal. What was the proposal? That used oil we can use for making lubricating oils. Then I try to get this used oil from the various hoteliers. Nobody was interested. Even Haldiram was not very much interested in doing this project. Why? क्योंकि उनका जो बचा हुआ ऑयल है वो छोटे छोटे जो समोसे वाले हैं वो सब लोग खरीद के ले जाते हैं लोअर प्राइस। यानी क्या है, प्रोजेक्ट के लिए प्रैक्टिकल वायबिलिटी भी देखना पड़ती है। इट इज अ गुड प्रपोजल दैट यू, मैं बोलता हूँ थाउजेंड्स ऑफ टन्स ऑफ दिस वेस्ट ऑयल इज अवेलेबल थ्रू आउट द कंट्री। इसको अगर अपन ने इससे अगर ग्रीस बनाए तो ग्रीस की कॉस्ट भी अच्छी है। one project I have done with a party in Chandrapur for making lubricating greases based on linseed oil. It is possible, but who will do it? And ultimately, as a technocrat, the availability of raw material is most important. Try to understand this point, that if you want to develop some new technology, the basic requirement is this, that how much the raw material is readily available to you. Say for example, for my PhD work, I worked on neem oil, karanj oil, undi oil, made good products, but then I went to the market and asked neem oil मिलेगा क्या, तो कोई देता ही नहीं था. पूरे नागपुर में एक अब्बू मियाँ करके आदमी है, वो नीम ऑयल देता है, वो भी 100 रुपए किलो. ऐसा नहीं चलता ना. जो भी आप रॉ मटेरियल चूज करते हैं, फर्स्ट थिंग बेसिक इज इट शुड बी अवेलेबल. हु विल अदरवाइज कमर्शियलाइज इट? आई मे क्लेम that my end product is good, but where is the raw material? That is the difficulty. Even in biodiesel, the same thing is happening. Availability on papers and actual availability, that you have to compare. जेट्रोपा के ऊपर सैकड़ों रिसर्च पेपर आ गए. जेट्रोपा ऑयल, जेट्रोपा ऑयल से ये होता है, जेट्रोपा ऑयल से ये फायदा है, वो फायदा है. आप मांगो जेट्रोपा ऑयल किसी से, कितना मिलेगा? पहले तो रिसर्च करने से पहले जो मटेरियल अपन यूज कर रहे हैं वो मार्केट में अपने को मिलता है क्या, ये पहले देखो आप. एंड विद व्हाट मच इजीनेस. देयरफॉर I diverted my whole research on materials which are abundantly available. Sugar is abundantly available, lakhs of tons is available, starch is available. When the material is available, then you can think of commercializing it. Liquid glucose available in thousands of tons, guar gum available in thousands of tons. तो पहले आपको अवेलेबिलिटी देखना चाहिए. और अभी इंडिया मार्ट पे 2 मिनट में availability का पता लग जाता है. Just click India Mart and you will be able to know that whether the material is available with whom and at what cost. हमको तो ये इंडिया मार्ट वगैरह नहीं था, तो हमको तो किस कीमत में क्या मिलता है ये समझने में बहुत टाइम लग जाता. अभी तो आप 2 मिनट में इंडिया मार्ट ओपन करोगे तो you will get every information. Is it not? Any other question, please? देखो ये बेसिक्स है ऑयल का, हाँ, ऑक्सीडेशन का, तो ये थोड़ा समझना बहुत जरूरी है आप लोगों के. हर डे अजिंक्य, समिधा, एनी क्वेश्चन? Okay, then we finish our this lecture, and tomorrow we will go for the processed oils for paints: boiled oil, stand oil, blown oil, melanized oil. Some of you are interested in melanized oil, is it not? So
Yes.
we will discuss that. Melanized
Yes, sir.
oil, styrinated oil, means modification of vegetable oils for the purpose of paints. That will be our discussion tomorrow. Okay. Thank you very much.
Thank you, sir. Thank you so much.
यश काय झालं?
हो सर.
तर
सर.
आता उद्या एक लेक्चर घेऊ आपण.
हो सर. सर
आज
मी
किती लोक अवेलेबल होते यार? किती लोक आज आले होते?
सर आज 13 जण होते प्रेझेंट, 4 जण अब्सेंट होते आज.
17 लोक आहे का आपल्या ह्याच्यामध्ये?
हो सर, हो.
बरं, एक मला सांग, मी आता खूप वर्ष झाली, मला LIT सोडून खूप वर्ष झाली. एक गोष्ट सांग की सगळ्या क्लासेसमध्ये मुलं किती प्रेझेंट असतात? 90%, 70%, 50%? काय आहे म्हणजे? इज इट ट्रू फॉर अस ऑर फॉर अदर्स ऑल्सो? काय पोझिशन आहे ऍक्च्युअली?
नाही सर, बाकीच्या क्लासेसमध्ये पण जवळपास एवढेच प्रेझेंट असतात, म्हणजे 13-14 जण, म्हणजे एवढेच असतात प्रेझेंट.
तुला सांगतो मी, मागे असंच झालं होतं, एक मुलगा क्लासला येत नव्हता. हम्म? त्याचे काहीतरी वेगळे प्रॉब्लेम्स होते, त्याचा काही मोजे विकायचा आणि त्याच्यातनं पैसे यायचे. त्याचं म्हटलं असं नाही. माझं डायरेक्टरशी त्यावेळेला म्हणजे आय हॅड ए फाइट विथ द डायरेक्टर की नो, क्लास में नहीं आया कोई तो उसको नहीं आने नहीं लूंगा. तो थोडासा आता काय झालंय की लोकांना क्लासमध्ये जाण्याचं इम्पॉर्टन्सच नाही वाटत आहे. काही काय झालं माहित नाही. एक तर गुगलमुळे सगळ्यांना काय वाटतं की आपल्याला सगळं येतं,
येस सर.
आणि आपण क्लिक केलं की आपल्याला सगळं येऊन जाईल. हे एक थोडासा गैरसमज झाला. पण गुगलवर असं नाही येणार. थोडंसं पर्सनल टच असल्याशिवाय नाही समजत गोष्टी काय.
येस सर.
एनिवे, ठीक आहे मग.
हो.
उद्या पुन्हा भेटू आपण.
हो
हां,
सर,
आणि
हो.
मला तुझे रिझल्ट्स आले की लगेच व्हिडिओ पाठव. आय एम व्हेरी मच इंटरेस्टेड इन गेटिंग
हो.
दोज रिझल्ट्स.
सर मी आत्ता
मला
पाहिलं म्हणजे
त्याच्यामध्ये पर्सनल फीलचा जो कॉलम आहे तो पाहिजे. त्याच्यामध्ये कलर, हां, फ्लो, फील